Okay, so we're going to begin this last section for this chapter, lesson 5-9. We're going to work on this in baby steps. We're going to take it through 3 steps. The first step we're going to do is we're going to look at how to incorporate graphing with what this section is all about. And this section is all about what's called linear programming. The idea here is we're looking at combining a lot of different items from this chapter, dealing with graphing inequalities, finding vertices of the feasible region, but what's new is we're going to be using what's called the maximum or minimum value function to figure out where we can either get our maximum answer or where our minimum answer is going to be, depending on the situation. Now, for this entire worksheet, if we look at step 4, we're going to be using this single function, 20x plus 40y. And I'm going to be using this worksheet that's going to be your assignment as our notes for this video to help us. So I think the easiest way to do this is just to jump right in and try it. Now, as far as the steps for this assignment, step 1 is optional. I'm going to show you how to do this without putting it in slope-intercept form. That'll be the last example we do in this video. But the very first step, or the thing that we want to do, is the main idea here is we're going to graph the system of inequalities. After we graph it, we're going to figure out what the vertices for that feasible region are. Now, those vertices are very important because those are the vertices, those are the values we put in this function to figure out what our maximum value is going to be. Or if we're dealing with a situation we're trying to minimize costs, or we're trying to find the minimum value, we'd put those vertices into that function to figure out which one would be the smallest value, which one would give us the lowest cost. So let's look at these. So if you notice here, we have y is greater than 0, greater than or equal to 0, and x is greater than or equal to 0. As a reminder, I call those our common sense inequalities. These are ones when we set up our system of inequalities, dealing with the story problem. They won't give us these two, but you want to make sure that you include them as part of your set, or part of your system. So y is greater than or equal to 0. Now remember, that is going to be a horizontal line going through where y is 0. And greater than or equal to 0 would include all the points above the line. X is greater than or equal to 0 is going to be a vertical line going through where x is 0. And it's greater than that, so we're referring to all the points to the right of that line. So right now I'm focusing in on quadrant 1. Now we're going to graph our other two. I'll do this one in purple. So these are easy because these are in slope-intercept form. So when I graph this, 1, 2, 3, 4, 5, 6 is right here. My slope is negative 2/3, so I go down 2 to the right 3. Down 2 to the right 3. Down 2 to the right 3. And this is going to be a solid line. And you want to make sure that your lines are as straight as possible. That's why it's important that we use our slopes so we can get more than just 2 points. Because in this way our graph will be more accurate, because our intersection points are going to be extremely crucial to get those accurate. Next, we're going to do this other line where my y-intercept is 4, and my slope is negative 1/3. So go down 1 over 3, down 1 over 3, down 1 over 3, down 1 over 3. And for both of these, we would shade below the line. So my feasible region that they're going to have in common is going to be this whole shape here. So that's my feasible region. So when they ask me for the vertices of my feasible region, those are the vertices we're going to use to figure out our maximum value. So again, our vertices are going to be the points where the lines intersect at. So the points are 0, 0, 0, 4, 6, 2, and looks like 7, 8, 9, 0. Now remember, this is not a vertice. It's not a vertex. That's just a single point. Sometimes students graph a point and they just assume that that's one of the vertices. A vertice is where 2 lines intersect at. So we only have 4 vertices. Okay, so now we're going to use those vertices. Remember, we have that profit function, or that maximum function. Another way to look at it is the function that's going to be maximized is 20x plus 40y. That's going to be true again for the entire worksheet. So to figure out the values at these feasible regions, we put these numbers in. So So if I put 0 in for x and 0 in for y, well, that's just going to be 0. If I put 0 in for x, well, that's 0. 4 times 40 is 160, so here our maximum value would be 160. If I put 6 in here for x, I get 120. If I put 2 in there for y, I get 80. Well, 120 plus 80 is 200. If I put 9 in there for x, 9 times 20 is 180. They ask us to circle the maximum value. So the maximum value here would be 200. Now let's look at how we graph it if it's in standard form. Let's look at this one. Okay, so our first step, again, y is greater than or equal to 0. So horizontal line going through where y is 0. X is greater than or equal to 0, that's a vertical line going through where x is 0. So the fact that these are both greater than or equal to 0 tells me my feasible region is going to be in quadrant 1. Now for these, you could rewrite these in slope-intercept form, but that's where I see a lot of students make mistakes. So instead, we're going to find the x-intercept and the y-intercept. And it's good to find the x and y-intercept first before graphing them. Because then if we need to change the scale at all to make this fit, we can do that. And the other thing that we're going to be finding too is we're going to find the slope for each of these. And we'll talk about that last. Okay, let's start with the x and y intercept. As a review, the x-intercept, which is where it crosses the x-axis, so it's where y is 0. So you can cover up the y and solve for x. My x-intercept would be 12. To find the y-intercept, you'd cover up the x and solve for y, so the y-intercept would be 6. For the next one, the x-intercept here is going to be 16, and the y-intercept is going to be 4. Now the slope for these, it's really important to remember that the slope is always the opposite of a divided by b when we have something in standard form. In this case, a is 1. So my slope would be negative 1 over 2, or negative 1/2. And this is going to be negative 1 over 4, or negative 1/4. The reason why that's important is sometimes, let's say if I was dealing with a smaller grid here that was only a 10 by 10 grid, well, if that was the case, my x's wouldn't fit. My y-intercepts would fit if I counted by 1, but my x's wouldn't. So it's always nice to be able to know what the slope is also, because even if I can fit these, like my x-intercept as I know is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, that's way down here, and my y-intercept is 6. 1, 2, 3, 4, 5, 6. Well, if I connect these, especially if I don't use a straight edge, chances are my graph isn't going to be straight. Even if I use a straight edge, chances are my graph might be at a slight angle, and it might miss the exact point of intersection. So I want to use my slope, the fact that it's negative 1/2, so go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, and you continue that pattern, and you should end at your x-intercept. Okay. Next, we're going to graph our other one. Here, I'm going to show you how you do this without putting down your x-intercept. Because let's say if 16 is, well, 16 isn't going to fit, we can see, because this was 12, 13, 14, 15, 16 would be off my graph. So, excuse me, in this case, my y-intercept will be 4. So I'm just going to use my y-intercept to my slope, just like we did back when we had this problem. That's all we used. We used the y-intercept and we used the slope. So using my y-intercept of 4 and my slope of negative 1/4, I go down 1 to the right 4, down 1 to the right 4, down 1 to the right 4, down 1 to the right 4. So you can see it's okay that my line goes off the graph here because we don't need that section. Okay. So now we just have to figure out what our vertices are. So to find our vertices, again, they're going to be these 4 points. So those are the points where we have lines intersecting there. So my vertices are going to be the point 0, 0, 0, 4 again, point 1, 2, 3, 4, 5, 6, 7, 8, and 2, and 9, 10, 11, 12, and 0. Again, our function that we're going to be maximizing is 20x plus 40y. I even have that on the top of each worksheet so you can see. So you don't have to flip to the front all the time. But it's 20x plus 40y. Well, if I put 0 in there, obviously it's going to stay 0. 0 for x, well, that's 0. 40 times 4 is 160. 20 times 8 is 160. 2 times 40 is 80. So that's 240. I put 12 in there for x and 0 in there for y. That also gives me 240. So this would be a situation where we have two maximum values. And again, what we're looking at is what these maximum values are telling us is maybe x and y represent two different products. So this would represent how many products of each I should make to be able to maximize my profits. So in a situation like this, a business might say, well, I could either make 8 of one product and 2 of another to make a total of $240, or I can make and focus on this product X, whatever that might be, and build 12 of those and none of the other ones, and I'd still have the same profit of $240. So these are things that businesses think about to figure out how to maximize their profits. Okay, so that's what we're doing. That's our focus on this first worksheet, just making sure we know and remember how to graph and how we use the vertices to find the maximum value. In the next video, we're going to be working on how to just set up the inequalities and how to set up the profit or the function that's going to be maximized or minimized. And then in the last video, we're going to be tying all of these together to figure out how we solve one of these problems from start to finish. So good luck.